Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, here we have been provided with the front view as well as the top view orthographic projections of the solid. Now, by using the information available with us in these two orthographic projections, we are required to draw the isometric projections of the solid. Now, since in this isometric projection, the front view face, the right hand side view face and the top view face of the solid, they will be clubbed into a single 3D isometric projection construction. So we need to evaluate the dimensions of the front face of the solid, top face of the solid and the side face of the solid. Now looking at the solid from the front side, so we observe that the length of the solid happens to be 60 millimeter. The height of the solid, it is equal to 50 millimeter. So we get the dimensions of the front view face equal to 60 millimeter by 50 millimeter. Now looking at the orthographic projection in the top view, so we have got the length equal to 60 millimeter and the width of the solid, it is equal to 40 millimeter. So the top view face will be measuring 60 millimeter by 40 millimeter. Whereas in the right hand side view, we are going to get the width of the solid as 40 millimeter and the height of the solid will be 50 millimeter. So the dimensions of the right hand side view face will be 40 millimeter by 50 millimeter. So since we have got the right hand side view, so this will be drawn on this side and this will be our front view face of the solid. So in the front view face of the solid, we know the dimensions 60 millimeter by 50 millimeter. So we are going to draw this length of the solid that is equal to 60 millimeter along the x-axis and the height of the solid will be drawn along the y-axis over here. So the front face will be constructed in the xy plane. So this is the x isometric axis, this is the y isometric axis. So within this xy isometric plane, we are going to get the front view of the solid. Similarly, regarding the right hand side view, so we know that the width of the solid happens to be 40 millimeter, which is drawn along the z-axis, and the height of the solid, it is equal to 50 millimeter, which is drawn along the y-axis. So the right hand side view face, it will be drawn along the YZ isometric plane over here. So this is the y-axis, this is the z-axis. So within this YZ plane, we are going to get the construction of the right hand side view face of this particular solid. And similarly, when we are looking from the top, so we are going to get the length of the solid as 60 millimeter while the width is equal to 40 millimeter. So in the XZ plane, we are going to get the construction of the base of the solid, and parallel to this XZ plane on the top side, we will be getting the construction of the top view face of the solid having dimensions 60 millimeter by 40 millimeter. Now let us evaluate the construction or geometry of this particular solid. Now when we are going to look at the solid from the front, so we observe that we can divide this solid into three components. So element number one, it is the horizontal wave. So this is the horizontal wave which we call as the bottom element or element number one over here. So this is having the dimensions length is equal to 60 millimeter, width equal to 40 millimeter and the height it is equal to 12 millimeter. Then on the top surface of the element number one on the rear side, we have got a vertical web over here which we are going to call as element number 2. So this element number 2 is having the length is equal to 12 millimeter over here and again the width will be equal to 40 millimeter. So this is the element number 2. Then we have the element number 3, which is a rectangular block having dimensions length equal to 25 millimeter, height equal to 20 millimeter and the width it is equal to 15 millimeter. And this rectangular prism or a rectangular block has been put on the top surface of the element number 1. So this rectangular prism or a rectangular web, it is resting centrally on top of this element number 1. So this is the top surface of the element number 1. So this rectangular web, it is resting centrally on top of this surface of the element number 1 over here. So this is the breakup of this particular solid, where we have been able to obtain element 1 horizontal web, element 2 vertical web, and element number 3, which is a rectangular web over here. So now we have to go for the construction of isometric projections of the solid. So in order to start with the isometric projections of the solid, we need to convert the true length dimensions which are available to us in these orthographic projections into the isometric length projections over there. So we have drawn the isometric scale over here, where we are going to mark all the true length distances on the true length scale, and the corresponding isometric length dimensions we are going to evaluate. So having evaluated the isometric length dimensions corresponding to all the elements over here, we are going to start with the construction of the isometric projections of the solid. So in order to develop the isometric projections of the solid, the first thing is we have drawn a horizontal datum line or a ground line over here. So having drawn this horizontal datum line, we are going to mark an origin point. So this is going to be our origin point. From the origin point, we are going to draw the isometric x-axis, which will be drawn towards left hand side, inclined at an angle of 30 degree to the ground. Similarly, from the origin, we have drawn the isometric z-axis, which is inclined at an angle of 30 degree towards right side at an angle of 30 degree over here. Now from this origin, once again, the y-axis will be drawn, which is going to represent the height of the solid over here. So we know that we are going to draw the front view face of the solid, and the front view face, it is this one. It is drawn along the left hand side over here. So along the left hand side, we know the dimension, that is length of the solid, it is equal to 60 millimeter. So we have marked the dimension of length of the solid equal to 60 millimeter along the isometric x-axis, and along the y-axis, the height of the solid equal to 50 millimeter has been marked over here. So having marked the length of the solid 60 millimeter along the x-axis and the height of the solid equal to 50 millimeter along the y-axis, now we can complete the front view face of the solid. In order to complete the front view face of the solid, so we need to draw an isometric edge over here measuring 60 millimeter, and this edge will happen to be parallel to the isometric x-axis. So with this construction, we have been able to complete the construction of the front view face of this particular solid. Let us now evaluate the construction of the right hand side face of the solid. So in order to construct the right hand face of the solid, we know that the width of the solid, it happens to be 40 millimeter. So we have drawn the width of the solid equal to 40 millimeter, and the height of the solid happens to be 50 millimeter. So in order to complete the right hand side view, we are required to draw an isometric edge which will be parallel to the y-axis, and it will be measuring 50 millimeter. Similarly, another isometric edge we need to draw measuring equal to 40 millimeter, and this edge will be parallel to the z-axis. So this is the construction of the right hand side view face of the solid. And then the top face of the solid can be completed once we draw this isometric edge parallel to z-axis measuring 40 millimeter, and we draw another isometric edge, this one parallel to the x-axis, which will be measuring 60 millimeter. So with this, we have completed the construction of the front view face, right hand side view face and the top view face. Now we need to complete the base of the solid. In order to complete the base of the solid, an isometric edge measuring 50 millimeter and parallel to the y-axis will be drawn. Another isometric edge which will be measuring 40 millimeter and parallel to z-axis will be drawn, and finally an isometric edge which will be measuring 60 millimeter and parallel to the x-axis will be drawn. So with this we have completed the construction of a rectangular prism. So this is nothing but it is a rectangular prism which is going to contain all the elements of this particular solid. Now we have got the basic framework for the construction of the solid. Now let us proceed with construction of each of these elements over there. So we have divided the solid into three elements. So the element number 1, it is a horizontal wave having a height of 12 millimeter, length 60 millimeter and width is equal to 40 millimeter. So corresponding to these three dimensions of the bottom wave or element number 1, which is a horizontal wave over here. Now we are going to draw a ring over here and it will be drawn at a height of 12 millimeter. So this ring will be drawn at a height of 12 millimeter. So this completes the construction of the bottom web over here. This is my element number 1. So having completed the construction of the element number 1, now I have to proceed to the construction of this element number 2. So in the element number 2, we observe that we have got this length from the rear side. So this is my rear face of the solid. So from the rear side, this length of the web or the thickness of the web happens to be 12 millimeter. So corresponding to this length over here, I have marked this dimension and a projection line which is parallel to the z-axis has been drawn at the top surface of the solid. So at the top surface we are going to get this rectangular projection corresponding to this vertical web, and the true shape of this horizontal rectangular web, this will be visible to us in the top view projections over here. So this is the top view projection which is going to give us the true shape of this rectangular portion of the vertical web, and this will be represented as an edge view in the front view. So as we are going to look at the solid from the front side, so this is the front side, so this edge view will be visible to us from the front side. Now having drawn this top surface, let us now draw this vertical edge over here which will be corresponding to this height. This height of element number 2 happens to be 38 millimeter because the bottom ring we had drawn corresponding to element number 1 having height is equal to 12 millimeter. Total height of the solid happens to be 50 millimeter. So this remaining height of the vertical wave will be equal to 38 millimeter, right? So this is 38 millimeter height which I have shown over here. So I have drawn a vertical projection line from this point as well as from this point also. I am going to draw another vertical edge over here, and this edge will be also terminating at the top surface of the ring number 1, right? So this way, once I complete this face over here, once I draw this isometric edge parallel to the z-axis, I am going to complete this surface of the vertical web. So this is my vertical web which is having this surface as its front face. So vertical web, that is element number 2, has been obtained. Horizontal web, that is element number 1, has been obtained. Now we are left with this rectangular web over here. So this rectangular web, it is located centrally on top surface of the element number 1. This is my top surface of the element number 1 which I can find out over here. This is my top surface. So we can see this is my top surface of element number 1. Now how much width does it have? It is having width equal to 40 millimeter. So the midpoint of this surface, as we are going to look at the surface from the right hand side view, so as we are going to look at this from the right hand side view, we'll find that the midpoint will lie somewhere here. Midpoint will lie somewhere here. So this is my front surface, bottom. So I need to mark this midpoint. So please check, I have marked this midpoint over here. So this is my midpoint of this horizontal edge. So this point will be located over here. Another thing I have marked besides marking the midpoint, so midpoint will be locating, giving me this point. So this axis line will be available with me while I mark this midpoint. Now after marking this midpoint, now the height of this rectangular web has been marked as 20 millimeter. So this is the height of this rectangular web which has been marked as 20 millimeter over here. So having marked this 20 millimeter dimension, now I am going to measure this dimension from this particular horizontal surface of the top surface of element number 1. So from here I have marked this distance equal to 20 millimeter and drawn a blue reference line over here which is going to give me top surface of this particular rectangular web. It is going to give me top surface of this rectangular web. Now having obtained this top surface, means this one, this top surface which is lying over here. Now having marked the surface, I have obtained the center point. So my center point will lie here. I know that the thickness of this web, this happens to be 15 millimeter. So what I am going to do, from this center point which is corresponding to this dimension, I am going to mark an offset of 7.5 millimeter on this side and 7.5 millimeter on the other side, right? So this is my center. I am going to move towards left side, that is front side, with an offset of 7.5 millimeter. Over here also I will be moving 7.5 millimeter towards the rear surface. So please check, this is my center line. So this center line has been marked over here. So having marked the center line, an offset of 7.5 millimeter on the left side and 7.5 millimeter on the right hand side has been marked. So 7.5 millimeter on the left side, 7.5 millimeter distance has been marked on the right hand side. So this gives me the thickness of the web. So please check, this is the width of the web or the thickness of the web. So I have been able to locate the width of the web which is located centrally. So this is located centrally onto this surface from the right hand side over here. So this width 15 millimeter has been marked, height 20 millimeter has been marked, and now I am left with only one dimension which is the length of this web. So length of this web happens to be 25 millimeter. So from this point, point 1, point 2, point 3 and point 4. So from these 4 points I am going to move parallel to the x-axis, and this length of the web I am going to mark as 25 millimeter, because this is 15 millimeter which is the width, this is 20 millimeter which is the height. So only dimension missing for this rectangular web, it happens to be the length of this web. So from these 4 points, so please check, now I am going to mark these 4 points, and this dimension 25 millimeter length I have marked over here. So this is 25 millimeter length of the web from the front face of this particular vertical web, from the front face of this vertical web over here. Now let me draw these edges. So this dimension I have marked as 25 millimeter. So this edge equal to 25 millimeter I have marked. This edge equal to 25 millimeter I have marked. Again another edge equal to 25 millimeter and another edge length equal to 25 millimeter have been marked. So this way the 4 points corresponding to this face, they have been obtained. So this face, 4 points they have been obtained in the isometric projection. Now I am going to join these points, and this rectangular surface looking from the right hand side will be obtained over here. So this completes the construction of the isometric projections of the solid. Now we are going to join the edges which will be visible to the observer. So let us start with the darkening of these edges. So when we are looking at the solid from the front view, so we can check the element number 1, the horizontal web will be visible to the observer. But we haven't darkened this portion over here. Why? Because in the front view it has been provided to us that element 1 and element 2, they have been integrated. They appear as a single web over here. So though for the ease of construction we have divided this into element 1 and element 2, but this is an integrated element over here. So because of this integration, this portion has not been joined. Now when we look at this vertical portion of the web from the front view, so we are going to join this portion of the vertical web from the front view. So this gives us an L-shaped web as we are going to look at the solid from the front. So this portion belongs to element number 1, and this portion of the web, it belongs to element number 2. Now let us darken this face, right hand side view face. So this portion of the element number 1 is visible to the observer. So this has been darkened. Similarly, the top portion, so this rectangular portion of the solid, it is visible to the observer. We can check this rectangular portion, it is visible to the observer in the top view. So since this is visible, so this has been darkened in the isometric projection. Now let us focus upon this rectangular web. So whatever elements of this rectangular web, they are visible, we have darkened those edges over here. So this front face is visible, and 3 of these length dimensions, they have been visible, and this base over here, and this connection point of the square web with this vertical web. So these 2 elements, they will be visible. So we have been able to see these edges, so we have joined these edges. Now we can observe that here we have this vertical web. Now portion of this vertical web edge over here, it has been covered by this rectangular block. So this we can't darken. Similarly, this horizontal portion, again this has been covered by this rectangular block. So this will not be darkened, only this portion will be darkened. Similarly, this portion will be darkened from the vertical web. Similarly, regarding element number 1, so this portion corresponding to this edge will be visible to the observer. So only this length of the edge will be darkened, whereas the remaining portion, it is not visible. It has been covered by this rectangular web. So this portion of the top surface of the element number 1 will not be darkened. So I have darkened this portion, number 1, I have darkened this portion, number 2, and number 3, I have been able to darken this portion. So this completes the construction of the isometric projections of the solid when the orthographic front view and the top view projections, they were available with us. So with this discussion, I hope that you would have understood about the basic procedure, how we can divide a given component into different elements, and how these elements, they can be integrated into the isometric projections over here, right? So this is all for today. So we'll be continuing with few more illustrations in the coming lectures. So thank you very much. Thanks a lot.